Here we are at example 3 from our 2.27 notes. We're asked to find the derivative of the function, and here it is at this particular point. In other words, we're looking for the slope that is tangent to this function at this particular x value 1. Now, in terms of our function, what that notation looks like is the slope of our function, or the tangent slope of our function at this particular point 1, comes out to then be the limit as h goes to 0. And pretty much anywhere that there is that x, we're going to go ahead and for the first part throw in that 1 plus h, in other words that target x value plus some h. So then we end up with 3 times 1 plus h quantity cubed plus 2 times 1 plus h minus 1. Again, this is that other y value from that other point minus our y value from our target point. So pretty much just throwing in this x value into the function and seeing what that corresponding y value comes out to be. We then end up with 3 times 1 cubed plus 2 times 1 minus 1. And again, this is all over h. So then we end up with the limit as h goes to 0 of 3 times, really this is 1 plus h times 1 plus h times 1 plus h plus 2 plus 2h minus 1 minus 1 cubed is 1 times 3 is 3 plus 2 times 1 is 2 minus 1, and this is all over h. Going ahead and foiling, we end up with 3 times, let's go ahead and just FOIL these first two. When we do that, we end up with 1 plus 2h plus h squared times 1 plus h plus 2 plus 2h minus 1 minus 3 plus 2 minus 1 just comes out to be 4. And again, this is all over h. We end up then with the limit as h goes to 0 of 3. And then going ahead and foiling this top piece again, we end up with 1. 1 times h is just h. Moving on to this next term, 2h. 2h times 1 is 2h. 2h times h gives us 2h squared. Moving on now to this last term, this h squared. H squared times 1 gives us h squared. And then h squared times h gives us h cubed. Plus 2 plus 2h minus 1. And again, we're still subtracting 4 from there. And this is all over h. At this point, we're going to go ahead and distribute in this 3. I'm sorry, actually we can go ahead and combine some like terms first. So we still have 1 that takes care of this guy. We have an h, another 2h, so that'll be plus 3h. We'll save a step here. We've got 2h squared, another h squared, so that's 3h squared. And then finally plus h cubed. So then we end up with the limit as h goes to 0 of 3 times, oops, yeah, we'll just rewrite it, 1 plus 3h squared plus h cubed minus 2, oops, that's plus 2, plus 2h minus 1 minus 4 all over h. Now going ahead and distributing, we end up with the limit as h goes to 0 of 3 plus 9h plus 9h squared plus 3h cubed when we distribute that 3 in, plus 2 plus 2h minus 1 minus 4 all over h. And so then we end up with the limit as h goes to 0 of, combining our like terms, we have this 3 plus 2 is 5 minus 1 is 4. So that takes care of these guys. We've already combined those. 9h can be combined with this 2h, giving us 11h. And it looks like those are the only things that can be combined together. So we have plus 9h squared plus 3h cubed minus 4 all over h. Then we end up with the limit as h goes to 0 of, looks like our 4's can actually be canceled out with one another, leaving us then with that 11h plus 9h squared plus 3h cubed all over h. Going ahead and factoring out that h, because if you were to try that direct evaluation right now, we'd get that 0 over 0 indeterminate form. So we do have to factor out that h. We then end up with 11 plus 9h plus 3h squared all over h. And here you can see those h's dropping out, thus giving us then the limit as h goes to 0 of 11 plus 9h plus 3h squared. And now we can go ahead and use that direct evaluation. So pretty much just throwing in 0, we end up with 11 plus 9 times 0 plus 3 times 0 squared. These guys will just pretty much all just drop out to be 0. So it looks like our slope of the tangent of this function at this particular point 1 came out to be 11. So kind of a lot of work. As you can tell, I'm just kind of curious how many lines this thing actually took. It looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines. 12 lines. A lot of extensive work just to get the slope that is tangent to this particular function at this particular point. And so, for example, 4, when we get to that, we're going to talk about a much more universal method that's going to be a lot faster, because as you guys can tell, this doesn't really necessarily seem like the most efficient. Like, it seems like our function, when it gets a little bit more complicated, it requires a lot more work. But again, though, that is example 3 from our 2.2 set of notes.